Welcome to the deep dive. Ever stop to think about the invisible threads connecting pretty much everything we do these days?
Hmm.
We're talking about computer networks. The tech that lets you listen to this, that powers global commerce, keeps us all connected. It's kind of mind-blowing how fundamental they've actually become.
It really is, yeah. From sending like a simple message to accessing these vast libraries of information, computer networks have just completely revolutionized how we live and work.
And how we interact, too.
Exactly. They're basically the essential infrastructure of our digital age, driving innovation across, well, countless sectors.
And it's not like this just sprang up overnight, right? We've gone from these early, almost experimental setups to the sleek, lightning-fast, and surprisingly secure systems we rely on now.
Definitely.
Think about it, instant online shopping, learning from anywhere in the world, even like breakthroughs in medical care are all built on this network foundation.
And what's truly remarkable is how it's still evolving. Technologies like 5G, they promise to unleash even greater speeds, better responsiveness.
Right.
And then there's the Internet of Things, sort of weaving connectivity into the very fabric of our environment. It's dynamic, constantly shifting.
So that's exactly what we're going to explore today. Our mission, if you will, is to do a deep dive into the nuts and bolts of computer networks.
Their origins, the core principles, how they actually work.
Yeah, and how they're shaping our world. We're drawing directly from our research here. Ever wondered how that email you just sent, like, zips across continents in seconds?
Or how massive corporations keep their, digital vaults locked tight.
Exactly. Let's unravel the fascinating story of computer networks.
Okay, let's do it. So maybe start at the beginning. What exactly is a computer network?
Good question.
Simply put, it's a collection of interconnected devices. Think laptops, your phone, servers holding websites, routers guiding data, switches managing local traffic.
All these different pieces of kit.
Right, all working together to share information across distances.
Okay, so picture all these gadgets chatting with each other. But where did this whole idea even come from, like the very beginning?
Well, the seeds were really sown back in the 1960s. There was this project called ARPANET.
Right, the military thing.
Yeah, funded by the U.S. Department of Defense. Imagine the goal was to create the first wide area network, or WAN. Basically letting researchers and government agencies share precious computing resources and data no matter how far apart they were.
So pooling brain power across the country, essentially.
Kind of, yeah. Sharing resources, really. A way to connect these big, expensive computers.
That sounds pretty revolutionary for the time. So how did that early experiment grow into the internet we know today?
Well, the 1970s were pivotal. That's when TCP/IP was developed.
TCP/IP, hear that all the time.
Right. Transmission control protocol, internet protocol. These are the fundamental rules that govern how data is packaged up, addressed, and routed across the internet. It was a game changer.
Why was it such a big deal?
Because it allowed different kinds of networks to communicate with each other seamlessly. It created a sort of universal language for the digital world.
Okay. So connecting networks that previously couldn't talk.
Exactly. And then things really took off. The 80s and 90s, that's when we saw the rise of local area networks, LANs.
So like in offices and stuff.
Yeah, exactly.
Yeah.
Suddenly offices, even homes, could have their own mini networks. Devices close together could share files, printers.
Makes sense.
And then, boom, wireless networking arrived, cutting the cord, giving us Wi-Fi, Bluetooth. That changed everything again.
It really did. Less clutter, too.
Absolutely. And the early 2000s brought another massive shift. Cloud computing.
Right. Storing stuff online instead of on your own machine.
Precisely. Data and applications weren't just local anymore. They could live in these huge remote data centers, accessible from anywhere with an internet connection.
Which must have put huge demands on the networks themselves.
Oh, absolutely. Greater demands on the underlying infrastructure. And, of course, the explosion of mobile devices, smartphones, tablets added a whole new layer of complexity. Networks had to become even more flexible, scalable, and crucially secure.
And the story's still being written. You mentioned 5G earlier.
Yeah, 5G promises blazing fast speeds, incredibly low latency, think near instant response times.
Which opens up possibilities for things like remote surgery or...
Exactly.
Yeah.
And the Internet of Things, IoT, where everyday objects, from your fridge to your thermostat, are becoming connected devices, sending and receiving data. It's a wild ride.
Okay, so let's get back to basics for a second. At a fundamental level, how does all this digital chatter actually happen? How does my cat video get from my phone to my friend across the country?
Right. It all starts with something called a data packet. Imagine your cat video being broken down into a series of small digital envelopes.
Okay, little pieces.
Yeah, tiny pieces. Each envelope, each packet, contains a bit of the video data and the destination address, kind of like sending a physical letter, with the recipient's address on it.
Okay, I get the digital envelope idea. But how do these envelopes know where to go? It's not like there's a digital postman driving around with a map.
Huh. No, not quite. That's where network devices like routers come in. Think of them as sophisticated traffic controllers for the internet.
Okay.
They examine the destination address on each packet and figure out the most efficient route for it to take. Then, within a local network, you have devices called switches that help direct traffic to the correct specific device.
So routers for the big picture, switches for the local neighborhood.
Sort of, yeah. All these components work together, making split-second decisions to get your cat video or your email or whatever where it needs to go, reliably and quickly.
So there's a whole system of digital road signs and traffic cops making sure everything arrives safely. And I bet there are rules to this digital road, right? You mentioned protocols before.
Precisely. Those rules are the network protocols. We mentioned TCP/IP. IP, the Internet Protocol, is like the addressing system, making sure each packet has a destination.
Like the street address on the envelope.
Exactly. Then you have TCP, Transmission Control Protocol. That's like a reliable delivery service. It makes sure all the packets arrive, that they arrive in the correct order, and it even handles retransmitting any that get lost along the way.
Okay, so that's for things where accuracy is key, like downloading a file.
Right. Then there's also UDP, User Datagram Protocol. It's faster, but less reliable. Think of it like sending a postcard.
Might get there quickly, might not get there at all.
Pretty much, yeah. And there's no guarantee of order. It's good for things like streaming video or online gaming, where speed is more important than ensuring every single packet arrives perfectly. These protocols, TCP, UDP, IP, they're the fundamental languages that network devices use to communicate.
All right, so we've got the what's interconnected devices and the basic how packets, routers, protocols. Now, let's dig into the actual building blocks, the essential parts that make up these computer networks.
Okay. Yeah, a computer network is really a symphony of different components working together. We can broadly categorize them. There's the hardware, the physical stuff.
Right.
Then the links, how they're connected, software, the instructions, network topology, the layout, network security, keeping it safe, and crucially, the network specialists in computers, with the people making it all work.
Okay, let's start with the hardware, the tangible stuff we can actually see or touch. What are the key pieces there?
Well, you've got the computers and servers themselves. They're sort of the workers and the storehouses of the network.
Yeah.
Then routers, which we mentioned, the navigators directing traffic between different networks.
Okay.
Switches are more like the internal organizers within a local network, making sure data gets to the right device on that specific network.
Got it.
And storage devices, of course, where all the digital information lives. Oh, and don't forget the network interface card, the NIC, in each device.
The what now?
The NIC network interface card. It's like the physical doorway, the port, that allows a device to actually plug into or connect wirelessly to the network. All this hardware provides the essential physical pathways for communication and resource sharing, accessing files, printing, browsing the web.
And then we have the links, the actual connections between these hardware bits. It's not all just invisible Wi-Fi signals buzzing around, is it?
Not at all, no.
Yeah.
Links are the physical or wireless pathways connecting devices. Wired links include things like traditional telephone lines, though less common now for data, the familiar Ethernet cables you plug into computers,
Yeah, I got those everywhere.
and high-speed fiber optic cables, which use light pulses to transmit data incredibly fast.
Right, the really fast internet often uses fiber.
Exactly. And then you have wireless links, which use radio waves, microwaves, other electromagnetic signals. That's what underpins technologies like Wi-Fi and your cellular network connection. Each type of link, wired or wireless, has its own characteristics: speed, cost, range, suitability for different situations.
Okay, so hardware provides the roads and endpoints, and links are the actual roads themselves, physical or wireless. But software is the brains of the operation, telling everything what to do. Is that fair?
That's a pretty good analogy, yeah. Software covers a lot. It includes the operating systems on our devices, the applications we use every day, and really importantly, the network protocols themselves, the rules we talked about.
Like TCP/IP.
Right. Network software provides the intelligence to manage and secure the network. It enables devices to understand each other and exchange information according to those established rules. Think of it as the set of instructions, the logic, that makes all the communication possible.
Now, network topology. That sounds a bit like, I don't know, city planning for data. Is it how the network is physically or logically laid out?
Exactly.
Yeah.
Network topology refers to the blueprint of the network, how things are arranged. Common arrangements include the start topology,
It's a star.
yeah, where all devices connect to a central hub or switch. Very common in home networks. Then there's the ring topology, where devices are connected in a circle.
Okay.
Mesh topology provides multiple redundant connections between devices, which is great for reliability. If one path fails, there's usually another way to get the data through.
Sounds robust, but maybe more complex.
It can be, yeah. And there's the tree topology, which is kind of a hierarchical structure, combining elements of star and other types. Each topology has its own pros and cons, cost, ease of management, how well it handles failures, that sort of thing.
That mesh one sounds important for resilience, especially when we think about security. Network security is obviously a huge concern today, isn't it?
Absolutely vital.
Right.
Network security covers all the measures taken to protect the network and its valuable resources from, well, threats, unauthorized access, cyber attacks, data breaches.
The scary stuff.
Yeah. This includes things like firewalls, which act as gatekeepers, monitoring and controlling network traffic coming in and out.
Like a bouncer for your network?
Kind of, yeah. Then there's encryption, which scrambles data to make it unreadable to anyone who shouldn't see it. Access controls restrict who can access specific parts of the network or specific data. And intrusion detection systems are constantly watching for suspicious activity.
Wow, a lot goes into keeping things safe.
It's a constant battle, really.
And you mentioned network specialists earlier. It's not just about the tech itself. There are people behind the scenes making it all run.
Absolutely. You can't forget the human element. The skilled professionals who design, implement, manage, and maintain these intricate systems are a critical component. Network managers, technicians, engineers, they need a deep understanding of all these pieces. The hardware, the software, the protocols, security.
To keep everything running smoothly.
Exactly. And to troubleshoot problems when they inevitably arise and ensure the network stays secure and efficient.
So we've looked at the fundamental components. Now let's maybe zoom out a bit and look at the different types of computer networks we encounter. I think most people are familiar with the Wi-Fi in their homes. That's a LAN, right? A local area
It's like you've nailed it.
Yeah.
Yes, LANs are the most common type we personally interact with. They connect devices within a limited geographical area. Think a single home, an office building, maybe a school campus.
Right.
They can be wired using those Ethernet cables or wireless using technologies like Wi-Fi or even Bluetooth for very short ranges. LANs are generally pretty cost-effective to set up, and they offer high data transfer speeds with minimal delay or latency, ideal for sharing resources like printers or files locally.
And then we have the opposite end of the scale, wide area networks, or WANs. These are for connecting devices across, well, wide areas, like different cities or even countries.
Precisely. WANs are designed to connect geographically dispersed locations. Think of a large company connecting its head office with branch offices across the country or even internationally.
How do they do that?
They use various communication technologies. It could be dedicated leased lines rented from telecom companies, satellite links, or increasingly, connections over the public internet secured using things like VPNs or even cellular networks.
Okay.
WANs tend to be more expensive to set up and manage than LANs, and sometimes the speed might be lower or the delay higher just due to the distances involved. But they're absolutely essential for organizations with multiple sites needing to communicate and share data.
Okay, so LAN for local, WAN for wide. Is there anything in between? I feel like I've heard of MANs.
Yes, Metropolitan Area Networks, or MANs. You don't hear about them quite as much in everyday conversation, but they fill that gap. They cover a larger geographical area than a LAN, typically spanning a city or a metropolitan region.
So bigger than an office building, smaller than connecting continents.
Exactly. They're often used by large organizations, maybe universities with multiple campuses within a city or government agencies, to connect their various facilities across that urban landscape. MANs often use high-speed technologies like fiber optic cables, sometimes dedicated wireless links.
Interesting. And finally, we have personal area networks, or PANs. That sounds like it's just about my own bubble of devices.
That's exactly what it is. PANs are focused on connecting devices within your immediate personal space. Think the devices around your desk, maybe in your car, or just the gadgets you carry with you.
Like my phone talking to my earbuds.
Perfect example.
Oh.
Or your laptop connecting to a wireless mouse or keyboard. Wireless technologies like Bluetooth are key here, also things like Wi-Fi Direct. It's all about connecting your personal tech ecosystem.
This really clarifies the different scales of connection, from personal space right up to global reach. Now, we touched on the skills needed by network specialists earlier. What are some of the core competencies someone wanting to work in that field really needs to have?
It's a pretty diverse and constantly evolving skill set.
Mhm.
At the foundation, you need solid network engineering and design skills,
Meaning,
meaning understanding network architectures, the different topologies we discussed, communication protocols like TCP/IP, industry standards, and critically, the ability to actually design and plan networks that meet specific needs, performance, security, budget, all that.
so the blueprint maker. What about keeping it secure? That seems huge.
Oh, absolutely critical. Network security knowledge is non-negotiable. Specialists need a deep understanding of security principles and the tools of the trade firewalls, intrusion detection and prevention systems, encryption techniques, access control methods. They need to know how to safeguard the network against the constantly evolving landscape of threats.
It sounds like a constant learning process.
It really is. The threats change daily.
And I'm guessing networks don't always just run perfectly smoothly. What skills are needed to, fix things when they break or slow down?
Right? Network performance analysis and troubleshooting are essential. You need to be able to monitor the network traffic, figure out where the bottlenecks are, identify other issues that might be slowing things down or causing errors,
And then fix them.
and then implement solutions to optimize performance and resolve those problems quickly. This often involves using specialized diagnostic tools and really understanding how the protocols work under the hood.
It's interesting that our sources also highlighted programming skills. I wouldn't immediately connect coding with network management. Why is that becoming important?
That's a great observation, and it's increasingly true. While it wasn't always the case, programming skills, particularly in languages like Python, are becoming super valuable.
Python for networks.
Yeah, Python is widely used for automating repetitive network configuration tasks, saves a ton of time, and reduces errors. It's also great for analyzing network data to spot trends or anomalies, maybe for security purposes, or even for developing custom network management or security tools.
So it helps make the job more efficient and insightful.
Exactly. It allows network pros to work smarter, not just harder, and gain deeper insights. Other languages like C++ or Java can also be useful for specific tasks like high-performance applications or building management tools.
And with so much moving to the cloud these days, I imagine familiarity with cloud platforms is also becoming a must-have.
Absolutely. Cloud computing is integral now. Network professionals need to be comfortable with virtualization technologies, things like VMware or Hyper-V,
Okay.
and also the major public cloud platforms, Amazon Web Services, AWS, Microsoft Azure, Google Cloud. They need to know how to design, deploy, and manage network resources effectively within these cloud environments, which have their own unique ways of doing things.
Makes sense. And of course, even with the best design and tools, things can still go wrong. So that ability to diagnose and fix network issues, troubleshooting that must be just core.
Without a doubt, network troubleshooting is a fundamental competency. You need to be able to systematically and logically figure out the root cause of a network problem. It takes a combination of using diagnostic tools effectively, logical thinking, and that deep understanding of protocols and hardware we talked about.
So if someone listening is thinking, hey, this sounds interesting, and they're looking to build a career in this field, what kind of academic background or professional certifications should they be thinking about?
Well, typically for many entry-level positions, a bachelor's degree in a related IT field is often seen as the minimum requirement. Think computer engineering, computer science, information technology, maybe network administration specifically.
So a solid technical degree.
Yeah, these programs provide that crucial foundational knowledge in networking principles, operating systems, maybe some programming, system administration. A master's degree can be beneficial for more specialized or research-oriented roles too.
And what about those professional certifications? Do they really help?
Oh, definitely. Professional certifications are highly valued in the networking field. They demonstrate practical skills and knowledge specific to certain technologies or vendors. Some key ones that come up a lot are the Cisco certifications, like CCNA, Cisco Certified Network Associate. That's a very common entry point. And the more advanced CCNP, Cisco Certified Network Professional.
Okay, so Cisco's a big player.
Huge. But there are others too. Microsoft has certifications like the MCSA, Microsoft Certified Solutions Associate,
Huh.
though they're shifting their certification structure. CompTIA Network Plus is a great vendor-neutral certification, good for foundational knowledge. And Juniper Networks has things like the JNCIA, Juniper Network Certified Associate.
So lots of options depending on your focus.
Exactly. Earning these certs can really enhance your resume, your career opportunities, and often your earning potential as well.
Okay, we've covered a lot of ground on what computer networks are and how they function and who makes them work. Now let's talk about the tangible benefits they bring. What are the main advantages of having these interconnected systems everywhere?
Oh, the advantages are massive, and they really permeate almost every aspect of modern life. I mean, improved connectivity is probably the most obvious one.
Just being able to talk to anyone, anywhere.
Right. Networks enable seamless communication, email, instant messaging, video conferencing, regardless of geography. This fosters collaboration, boosts productivity, definitely reduces travel time and costs.
And enables remote work, which is huge now.
Absolutely. Then there's resource sharing. That's another big win.
You mentioned printers earlier.
Yeah, printers, scanners, storage devices, even specialized software applications can be shared among multiple users on a network. This leads to significant cost savings. You don't need a printer for every desk, and increases efficiency because people can access resources simultaneously.
File sharing, too, right? Working on the same documents.
Exactly. It makes collaboration on documents and projects incredibly efficient, even if the team members are in different buildings or different countries.
Centralized data management also sounds like a huge plus, especially for businesses worried about security and backups.
It is indeed. Storing data centrally with proper access controls significantly enhances security compared to having sensitive data scattered across individual laptops. It also drastically reduces the risk of data loss from device failures or theft, assuming backups are handled well.
Which is easier when it's centralized.
Much easier. Plus, networks offer remarkable flexibility. Users can use various communication methods, access information on the go, via wireless networks. This is crucial for supporting mobile workforces and providing remote access to critical business resources.
And with the sheer volume of data we all generate these days, I imagine increased storage capacity is a major advantage too.
Absolutely. Networks, especially when combined with cloud storage, provide the ability to store vast amounts of data and backup centrally. You're not limited by the hard drive in your laptop anymore. It's scalable and accessible from pretty much anywhere.
And ultimately, does all this save money?
Generally, yes. The cumulative cost savings can be substantial. By sharing resources, streamlining processes, reducing manual management, cutting down on travel, and improving overall efficiency, organizations can definitely realize significant reductions in IT and operational expenses.
So we see the widespread advantages. Now let's maybe look at some concrete, everyday examples of how computer networks are just woven into the fabric of our lives.
Right, we interact with them constantly, often without even thinking about it. Just consider basic contact, how we stay in touch. Email, social media platforms, video calls like Zoom or FaceTime, even simple SMS text messages.
All rely on networks.
Every single one relies on these underlying networks to connect people and allow that instant sharing of information across the globe. Wikis, blogs, all part of it.
Network storage is something I think more people are using at home now too, not just businesses.
That's true. Network-attached storage, or NAS devices, are becoming more popular. They provide a sort of personal cloud, a centralized and secure way for individuals or small businesses to share files within their home or office network and back up their important data. It's more robust than just relying on external hard drives.
And then there's actual cloud storage, which is everywhere.
Indeed. Platforms like Google Drive, Dropbox, iCloud, they allow users to store files and data on remote servers, accessible from any device with an internet connection. It offers amazing convenience, scalability, and data redundancy.
E-commerce obviously wouldn't exist without networks.
Not a chance. E-commerce has completely revolutionized how businesses operate and how we shop. Online transactions, online banking, secure financial transfers across the globe, all fundamentally dependent on reliable and secure computer networks.
And let's not forget how many of us make phone calls now. VoIP seems to have largely taken over.
It really has, especially in business but also residentially. Voice over Internet Protocol, or VoIP, allows phone calls to be made digitally using Internet protocols instead of the old analog phone lines. It's often cheaper and offers way more features.
Well, this deep dive has really illuminated the vital role computer networks play in our interconnected world. It's kind of staggering when you step back.
It really is.
We've explored their fascinating origins, from ARPANET onwards, the ingenious principles that make them work, packets, protocols, routing, the essential components, hardware, software, links, the different types serving different scales, LANs, WANs.
The specialized skills needed to manage them, the huge advantages they bring.
Right, and just the countless ways we rely on them every single day, often without a second thought.
And as we've seen, the field of computer networks is anything but static. It's constantly evolving, adapting to meet the ever-growing demands of our increasingly digital society.
Always something new around the corner.
Exactly. And it's providing the foundation for new and emerging technologies, AI, IoT, whatever comes next, that will continue to shape our future.
So, as you, our listener, navigate your day, maybe take a moment to appreciate just how deeply computer networks are integrated into your routine. From the moment you unlock your phone in the morning to the complex global systems that power trade and communication, it makes you wonder, what exciting new possibilities do you think lie ahead as we become even more